Let's take a look at number 2. An experiment consisted of rolling a 6-sided die and then flipping a coin. List the sample space in each probability. So I've got 2 events here, right? I've got rolling a 6-sided die, and then after I roll my 6-sided die, I'm going to be flipping a coin. So let's start by setting that up. First, I'm going to roll a die, and then I'm going to flip a coin. When I roll a die, one of 6 things could happen. I could get a 1, or a 2, or a 3, or a 4, or a 5, or a 6. Let's pretend I rolled a 1 on my die. Now it's time to flip a coin. If I roll the 1 on the die, I could get heads on the coin, or I could get tails on the coin. Let's pretend I rolled a 2 on the die. The possible outcomes for the coin don't change. I could still get either heads on the coin or tails on the coin. If I get 3 on the die, again, my possibilities don't change for my coin. I could either get heads on my coin or tails on my coin. So when I map out this tree, what I'm doing is I'm listing all of the possible outcomes when I look at these probabilities together. So at this time, I'd like you to pause the video, please, and try to complete the rest of the tree on your own. Pause the video now, and when you're done, resume it so that you can check your answer. Take a look at my probability tree. It shows all the possible outcomes of what will happen if I first roll a die and then flip a coin. For example, if I follow along this path, it means that I first rolled a 4 on the die and then flipped tails on the coin. I would list that outcome as 4T, meaning 4 tails. All right, so this tree right here, this is one way to list my sample space. It is a visual representation of all the possible outcomes that could occur when I roll a die and then flip a coin. Another way that I could list a sample space is to just make a list. Here you can see another representation of the sample space for this compound event. We've listed the possibilities for rolling the dice and the possibilities for flipping a coin. In the last example, we were looking at 2 probabilities that were each 1/2. This time, we're looking at probabilities for the first event, which are all 1/6, because there are 6 possible outcomes when I roll a die, and each one outcome is 1/6 of the total outcomes. So the probability of rolling a 3, for example, is 1/6. That's different from the probability of flipping a coin. The probability of each event when I flip a coin is 1/2. But every time I flip a coin, the probabilities are consistent. And every time I roll a die, the probabilities are consistent. So what that tells me is if I look at any one of my outcomes, there are 12 total outcomes. The probability of any one of those outcomes, so for example, the probability of 2 and then heads, that's one of my 12 total possibilities. So the probability of getting a 2 and then heads is 1 out of 12. As always, we should write our probability as a fraction, decimal, and percent. So 1/12 I could also think of as 0.08 or 8% roughly. If you wanted to be a little more precise, you could say 0.083 or 8.3%. Given what you've learned from these 2 videos on compound probability, please try number 3 on the back on your own. When you're done with that, feel free to watch the video that follows in order to check your answer, but try it on your own first.